Hello, good morning. Welcome back to my YouTube channel. Again, this is Mr. Santos Capellan Jr. Always wishing you a nice day. Okay. Now, today, what I'm going to do is try to discuss water cooled chiller or chiller plant manager that control and monitor a water cooled chiller. Okay. Actually, there are two types of chillers. One is the air cooled chiller and the other one is water cooled chiller. Okay, now the only difference is in water cooled chiller there is a cooling tower to cool the water or to cool the condenser water. Now in air cooled chiller uh, there is no cooling tower, then you only have a condenser fan to cool the refrigerant. Okay, now in water cooled chiller water is being used to cool the refrigerant. Okay, so it can go back to the uh, so I mean there will be different stages that the refrigerant will pass through. Okay, now so water cooled chiller we have several I have prepared several slides for this video tutorial. Okay, let me go to the next slide. Now, in my previous tutorial, I already discussed this chilled water system overview. Okay. Now, actually, this is the main graphics for a chiller plant manager for a water cooled chiller. Okay. When you say main graphics, in that main display or in that BMS graphics, you will be able to see in one glance what is happening in your system. Okay. You will be able to see what is going on in your cooling towers. You will see some of the important monitoring points like the temperature entering the cooling tower, each cooling tower, and the temperature of water leaving the cooling tower. And of course, you will be able to see also the butterfly bulb status. As you can see here, each cooling tower, there will be one butterfly bulb for the entering water, and there are two butterfly bulb for the leaving water. Okay. So you will be able to see also the main uh, condenser water going back to the chiller. As you can see in this piping layout, there are two cooling towers connected. Okay, so there will be two condenser header here, as you can see in the graphics. Okay, so 1 and 3, uh, it's like one set, and 2 and 4, it's like one set of cooling tower. Okay, so then after the cooling tower, it will show you the status of the condenser pumps. Okay. So as you can see here, you will just see the animation, which pump is running. So we have 4 pumps. So there will be some animation. Likewise, in this cooling tower, you will be able to see the number of fans working in each cooling tower. Okay. So for the cooling towers, all in all, we have 12 condenser fans, okay, or 12 cooling fans, okay, cooling tower fans. Now, okay, let me go back. Here you will be able to see also the running status of chillers, okay. In this system, we have 4 chillers. Now, each chiller, it has also what you call this butterfly bulbs, okay. As you can see, one butterfly bulb for the entering condenser water and one butterfly bulb for uh, entering chilled water, okay, coming back from the supply load. Okay, so cooling tower chillers, then you have the primary pumps, cooling tower condenser pump chillers, then you have the primary pumps. Now actually primary pumps will be the one to pull the chilled water back to the chiller from load side. Okay, then we have here also secondary pumps, that is the one delivering the chilled water to the load side. Okay, now if the load side is like there will be several buildings, then if the buildings have several floors, then you will be having there tertiary pumps that we will push the chilled water up to the roof level of the building. Okay, so this is the main what you call this, the main menu or the main display for this chilled water system. Okay, now let's talk specifically for each component of the system. Okay, now what I have here in my next slide is the chiller itself. Okay, so for the chillers, there will be some field devices that will be installed and some monitoring points that needs to be displayed so that the operator will be uh, aware of what is happening in the chiller that is running. Okay, so what are the field devices? Actually, the field devices are the flow meter. Okay, flow meter for the condenser water and flow meter for the chilled water. Then the temperature. Okay, so temperature, then the butterfly bulb. We have butterfly bulb here. Okay, one in the condenser side and one in the evaporator side. Then we have flow meter. Okay, we have flow meter. Then we have temperature. Okay, now here uh, you can see here some of the monitoring points like chiller trip status. Okay, it will show if the chiller is in fault condition. Okay, then it will show also the running hours. Now actually I already discussed what is running hours, what is the purpose of running hours. That is to know it will be used for the maintenance. Okay, now here you will be able to see some of the important points that needs to be monitored in the chiller, like chilled water flow. Okay, so what is the amount of chilled water flowing in the chiller, because if very less chilled water flowing in the chiller, then it might trip. Okay, to prevent freezing. Okay, now condenser water flow. Okay, so as I said, there will be flow meter installed in the condenser side and evaporator side. Then you will be monitoring also the compressor discharge temperature, oil tank temperature, evaporator pressure, condenser pressure. Okay, so this is for the engineers to be able to know if there is some problem in the chiller by just looking at the different monitoring points. Okay, now I will show you this in bigger display in the next slide. Let me go to the next slide. Now for the cooling tower. Okay, for the cooling tower, what are the information that this system will display? Okay, now here, as you can see here, there will be one butterfly bulb in the entering condenser water. Then there are three fans. Okay, then this catch basin here, we have two outlets there. Okay, then two butterfly bulbs. Okay, so what you will see there is the living water temperature, then the status of cooling bulb. Then here, as you can see here, we have here a makeup water uh, inlet. Okay, then again there is a butterfly bulb here. Okay, now then you have here some monitoring points, water level, high alarm. Okay, so there it will display also if the level of the water in uh, the cooling tower basin is in the high level. Okay, then water level low alarm. Okay, then water level low alarm. Okay, this is very important because as I said, the level of the water in the basin should be always maintained to prevent air from entering the uh, pipeline. Okay, because if there is air in the condenser pipeline, then it will give some problem. It will create problem in our system. Okay, so in order to prevent air from entering the pipeline, we have to maintain the water level. Okay, now let's say there are because of evaporation and some leaks in the system, again the water will go to the water will be less or it will diminish. Then to be able to compensate the water loss, then we have here a makeup water. Okay, to maintain the correct level of the water in the cooling tower. Okay, so what else? Makeup water valve status, so you can see if the status of this is open. Then chilled water dosing pump alarm. Okay, it's showing also chilled water dosing pump alarm, because as you know, this condenser water, it should be properly cleaned and treated. Okay, because as you know, this cooling tower is in the open area. Some dirt or debris can enter the cooling tower. Okay, so should be always cleaning and chemical dosing for the condenser water to make sure that the water is clean and suitable for the chilled water operation. Okay, now let me go to the next slide. Okay, the next slide will show you the primary chilled water pumps. Okay, so primary chilled water pumps, as I said, these are the pumps that is pulling back the chilled water delivered to the load back to the chillers. Okay, so what are the information being displayed here? We have the run status. Okay, so for each pump it will display the run status. Okay, then the trip status. These are very common monitoring and control points for set of pumps. Now we have the hand of auto status. Okay, hand of auto status. Command. Okay, this is the start and stop command. Then runtime, again, runtime is also displayed here. Then alarm status, reset alarm. There is a provision to reset the alarm if, let's say, the one of the primary chilled water pump trip. After rectifying the problem, then you can reset the alarm. Okay. Usual start stop time. Okay, there is some time delay before it will start. So here, that is 30 seconds. Now these parameters will be always flexible. The operator can adjust this startup time. Then valve close to pump start. So there is also 5 delay. Okay. Now here is the animation of the pump. When the pump is running, then it will be on green color, then it will be rotating and animating. Okay, so this is primary chilled water pump. Now let's go to the next. Then this is the secondary chilled water pumps. Okay, secondary chilled water pumps are the pumps that delivers the chilled water to the load side. Okay, now as you can see, the control and monitoring points are the same. Okay, so whatever is displayed in the primary pumps, it will be also the same format in secondary chilled water pumps. Okay, now here the extra thing or the extra information that is displayed here is the system pressure. Okay, then you have also here the differential pressure. Now this differential pressure is the one that will control the speed of the pumps or speed of the secondary pumps. As you can see here, there are 3 secondary pumps running. Okay. Now, system pressure, this is the pressure should be maintained. Okay. Now, let's say there is a small leak in the system, then the chilled water pressurization system or the pressurization pump will kick in. Okay, to maintain the pressure set in the pressurization pumps. Okay. So likewise, run status 3, find about the status command. Then here, there is a VFD speed and feedback. Now it's showing the speed and feedback. Okay. Now here, I think this one, I grabbed the screen during the manual operation of the chiller. Okay. So during the first few days of running these chillers, some chillers are being run in manual. Okay. It is not yet set to fully automatic operation. Okay. Now, okay, so this is the secondary chilled water pumps. Now let's go to the condenser pump. Now the condenser water pumps, again, this one is the condenser pump that pushing the condenser water to the condenser circuit of chiller, or pulling back the condenser water from cooling tower to the condenser side of the chiller. Okay, the same control and monitoring points. Run status, trip, hand up status, command, runtime, alarm status. Okay, so basic control and monitoring points for pumps. Now here, this is the chilled water dosing pump. Now this is the dosing pump for chilled water. Okay, so meaning, no, this is for condenser water. So this is the one treating the uh, condenser water. Okay, so it injects chemicals for the treating of condenser water. Actually, there is also a set of chilled water uh, dosing pump. Okay, because the chilled water it should be also treated to prevent some corrosion in the chilled water pipeline. Okay, so there are two sets of dosing pump, one for condenser water and the other one for chilled water. Okay, let me go to the next slide. Okay, so this is the makeup uh, pumps. Now the purpose of makeup pump is to maintain the level of condenser water in the basin of each cooling tower. Okay, so as I said, there will be one butterfly valve going to its cooling tower. Okay, so when there is a low level alarm in that cooling tower, then this valve will open, then the pump will run. Okay, then when the level of the water is in the right level in that cooling tower, then the pump will stop and make up water valve, the butterfly valve will close. Okay, as you can see here, cooling tower 3, there is a low level there. That's why the valve opens, then one of the pump will run. Okay, now let me go to the next slide. Chilled water pressurization. This is the one that maintains the pressure of the system. Okay, so when the pressure of the system drops, this will be the one to pressurize or repressurize the system. Okay. Now, of course, there will be always some leaks in the chilled water. So this one will be the one to maintain the pressure in the chilled water system. Okay. Now, these are the points that are being monitored in each chiller. Okay. So chilled water flow, condenser water flow, compressor discharge temperature, oil tank temperature, evaporator pressure, condenser pressure, oil tank pressure, oil pump pressure, current, what is the current being drawn by the chiller or the compressor, then vane of opening rate, okay, this is the opening of the for the refrigerant, okay, condensation temperature, current limit approach, okay, hot gas valve output, chilled water set point, unit run type, motor current limit, system alarm, reset system alarm. So these are all the points being monitored in each chiller. Okay. Now this one is showing not the real-time value because I think the software integration from the chiller to the uh, this system is Metasys or Johnson control is not yet completed. Okay. Now this one is chiller staging. Okay. And now there are 4 stages. Okay, so stage 1, the activation set point is 8 degrees. Let's say when the temperature, the chilled water temperature is 8 degrees, then it will be stage 1. Now, if the chilled water becomes 10 degrees, then we'll call for stage 2. Okay, so when the chilled water becomes 12 degrees, then it will call for stage 3. Okay, now there is also the activation. So let's say you are in stage 1, then the temperature go to 6 degrees, then it will stage 1 will be deactivated. Okay, so in stage 2, 2 chillers running, then when the temperature of the chilled water go to 8 degrees, then stage 2 will be deactivated. Okay, again here also in stage 3, the activation is 9 degrees. Let's say when the chilled water go to 12 degrees, okay, then it will enter the stage 3. Then when the temperature go to 9 degrees, then it will go out of stage 3. Okay, stage 3 will be deactivated. Okay. Now, there are also some information here. Stage up delay, there will be always 600 seconds before it will go directly to that stage. Okay, so this is the delay time before you will go to the other stage or to the next stage. Then stage down delay, you also have 600 seconds. Now these parameters are flexible. The operator can change this one. Okay. Now let's go to the next stage. Next slide. Cooling tower basin cleaning unit. Now the purpose of this one is to clean the uh, cooling tower basin, okay, because the basin will catch, especially if it is in the Middle East. As you know, there will be sandstorm. Then this basin will collect some sand, and it should be uh, removed from the cooling tower basin. Okay, so the water there will be like stir up to remove this sand at the bottom of the basin. Okay, then there will be a filter to filter this dirt that is accumulated in the basin of the cooling tower. Okay. Now here, this is the CPM view. Okay, when you are in this display, you will be able to see which chiller is running. Is there fault in the chiller? If the chiller is being commanded, as you can see here, run. Okay, chiller is running. Fault status all normal. Command. Okay, there is no command, but the chiller is running, meaning the chiller is running in manual. Okay. Now alarm latch. If there is alarm, reset alarm, evaporator entering in leaving temperature. So you will see the entering and leaving temperature in the evaporator. Then likewise in the condenser, you will be able to see also the entering and leaving temperature. Then you can see also the cooling bulb command and status, chilled water bulb command and status. Okay. Now you can disable the unit. Let's say there is a problem in one unit, you can disable here so that it will not be included in the chiller staging. Use chiller usual startup time is 200 seconds. Before the chiller will be started, it will wait for 200 seconds. That is on delay. Bulb usual opening time is 100 seconds. This is the time when the butterfly bulb will fully open. Okay. Time to circulate chilled water after chiller stops. Okay, there is second 600 seconds. Okay. Chiller on delay 200 seconds. Time day. Okay, there is also time if it is day or night. Okay. Plant shutdown. If you will make this true, then the plant will shut down, or the water cooled chiller plant will shut down. Okay, so this is the chiller plant manager view. Okay, so that's the end. Okay, to wrap it up, I've shown you the main display. Okay, then the information being displayed in a single chiller, in each chiller, then the information displayed in each cooling tower, the primary chilled water pumps, okay, secondary chilled water pumps, condenser water pumps, the condenser water dosing pumps for cleaning the condenser water, makeup pumps for maintaining the condenser water in the cooling tower basin, pressurization pump to maintain the pressure in the chilled water line, chiller information, the parameters or the information that needs to be monitored by the chiller operator. Then the staging set point, when another chiller will be called or when another chiller will be removed. Okay, this is the chilled water, the chiller shedding and adding. Okay, then BCU. Okay, this is the this is the cleaning unit pump. Okay, so this is responsible for cleaning the cooling tower basin. Then this is the CPM view. You can see what is happening in the chillers, how many chillers are running, okay, and some other important points in the chiller. Okay, so that's it, guys. I think I have given you enough information. If you will become a BMS engineer, that will try to prepare a graphics for a water cooled chillers, and you have already an idea how are you going to present its graphics and what are the information that you need to display, okay, for the control logic program of this. Basically, the uh, the supplier of this system, they have their own CPM. They will deliver their own DDC, and they have an engineer that will program the operation of this water cooled chiller. Because as you see, the the system is a little bit complicated, so they have developed a control logic program for this specific application. Okay, but if you're a BMS engineer, then let's say there are only two chillers and several pumps, primary and secondary. Now it will be easy to do the programming because it is not so complicated. Okay, so once again, thank you very much for watching my video tutorial. And if you are new to my channel, please subscribe, and you can click also the notification bell. And again, Santos Capitan Jr. saying God bless us all, and bye for now.